Good day, sir. Good day, cadets. We are the Group 2 and we are going to discuss the effects of wind, current, squat, shallow water on ship handling while maintaining safety of navigation. So, the repertoire of this group is yours truly, the Cadet Masbang Rosemary I, the Cadet German Cliff Roger, the Cadet German Christian B, the Cadet German John Lloyd, the Cadet Gloria John Paul, the Cadet Mantua Jaff, the Cadet Hinon Joselito, the Cadet Mamak Ray Anthony, the Cadet Kizon Adrian, the Cadet Ferlino Mil Joshua J, the Cadet Kuyag Carlo M, the Cadet Diamos Genesis, the Cadet Mabugat Joan Marie, and last but not least, the Cadet Lago Pacifico. For the learning objectives, explain the effect of wind, current, squat, shallow water on ship handling while maintaining safety of navigation. Explain the effects of wind on ship handling while maintaining safety of navigation. Vessel head to wind with headway. Vessel making headway through the water and heading directly into the wind. W is now well forward of amidship and in fact very close to P. The wind is exerting no turning moment or sideways force on the vessel. A comparatively small change in relative wind direction, either by alteration of course or wind fluctuation, will place the wind on the vessel's bow. The whole of one side of the vessel will now be exposed to the wind and W will move off.
So first is a turning force, which will now develop a turning moment about P, tending to turn the vessel into the wind again. And second is the wind force, which will also develop a sideways force on the vessel away from the exposed side. Head to wind, therefore, the vessel is course stable, provided that she maintains headway through the water. If the ship has a large stream by the stem, W will be further forward. With a reduction or even loss of course stability, this can sometimes result in a rapid and violent loss of control.
Vessel head to wind with sternway. Ward. While P has moved off, the wind is exerting no turning moment or sideways force. A comparatively small change in the relative direction of the wind will move W off, however, P remains off to W. The following effects will now be experienced. A. The wind force will develop a strong turning moment about P, tending to turn the vessel's bow farther away from the wind. B. The wind force will develop a sideways force on the vessel, away from the exposed side.
I'll explain the head to wind. As soon as the vessel starts to make sternway through the water, she loses course stability, and the bow will pay off away from the wind, sometimes quite rapidly. If the ship has a large stream by the stern, west may move farther forward, perhaps quickly, and the loss of course stability is even more pronounced. This can sometimes result in a rapid and violent loss of control.
Vessels turn to wind with headway. Vessels making headway through the water and with the wind directly astern. P is forward a long distance from W, which is well off. A comparatively small change in relative wind directions will move W forward. However, W is still some distance above P. The following effects will now be experienced. A. The wind force will develop a strong turning moment about P, tending to turn the vessel's stern further away from the wind. B. The wind force will develop a sideways force on the vessel away from the exposed side.
Making headway with stern to wind, the vessel loses course stability and is difficult to steer, but effect is greater when there is also a following sea or swell. If the ship has a large stream by the stern, W may move farther forward and loss of course stability by the generally less pronounced but still a potential danger.
Vessels turn to wind making sternway. Vessel making sternway through the water, and with the wind directly astern, P has moved aft fairly close to W, which remains even farther aft. A change in relative wind direction will eventually move W forward of P. Following effect will be experienced. A. The wind force will develop a turning point about P and turn the vessel's turning back into the wind. B. The wind force will develop a sideways force on the vessels, away from the exposed side, making sternway through the water. With stern to wind, the vessel is again course stable. If the ship has a large trim by the stern, W may move farther forward, generally improving course stability. However, with such a trim, there is always the possibility of unpredictable loss of control calculation.
Explain the effects of the current of the ship handling while maintaining safety of navigation. So ocean currents play a very important role in ensuring the stability of the ship. The effect of the currents therefore must also be considered when handling ships in waters. Effects of current are important, especially when the ship is under the effect of onshore winds near offshore platforms while maneuvering in narrow channels, in open seas, or in inland waters or harbors. When the ship is in harbors or inland waters and the current is at constant strength and direction, the ship's handling becomes considerably easier.
Such conditions exist only in comparatively narrow channels of the rivers. However, navigational officers should take into account different current streams that can exist over a small area within which the vessel has to maneuver. The main difference between currents and the winds is that currents affect the ship in definite and predictable ways, unlike the wind does.
Explain the effects of current on ship handling while maintaining safety of navigation. Even in open waters, when the ship is approaching a rig or mooring buoy, due allowance should be made for the effect of the current for a secure maneuver. Current from ships ahead will reduce the ship's speed over ground, improve ship's response to the radar, and also give more time to assess and correct developing situation.
Explain the effects of squat on ship handling while maintaining safety of navigation. So, when a ship proceeds through water, it pushes the water ahead. So this volume of water returns down the sides and under the bottom of the ship. So the streamlines of return are speeded up under the ship, causing a drop in the pressure and resulting in the ship dropping vertically in the water.
When the ship drops vertically in the water, it trims both forward and aft. This overall decrease in the static and the keel clearance both forward and aft. It is called ship squat. If the ships move forward at a greater speed in the shallow water, when the keel clearance is 1.0 and 1.5 meters, then there is a highest chance of grounding at the bow or stern due to excessive squat.
So explain the effects of shallow water on ship handling while maintaining safety of navigation. The effect of shallow water on a ship is: first, more ship's power is absorbed by the water due to increased friction. Next, usually sinkage is greater forward than aft for ships of tanker speed and displacement in any depth. Next, turbulence interferes with rudder and propeller effectiveness, signs that the ship has entered shallow water conditions. Next, wave making increases at the forward end of the ship. Next, ship becomes more sluggish to maneuver.
Effect of shallow water on a ship. RPM indication will show a decrease if the ship is in open water condition without bed restrictions. This decrease may be 15% of the service RPM. If the ship is in a confined channel, this decrease in RPM can be about 20% of the service RPM, and there will be a drop in speed. If the ship is in open water conditions, it may amount to a drop of 60% of the service speed. And the ship may start to vibrate suddenly because of the entrained water effect, causing the natural hull frequency to become resonant with another frequency. Pitching reduced due to cushioning effect of water under the keel.